Good morning, students. Today we are going to discuss new topic, that is X-ray. In this topic, we are going to cover these points: principle, properties of X-rays, production of X-rays using Coolidge tube, types of X-rays, and applications of X-rays. Students, as we know, X-rays were discovered by scientist William Röntgen in 1895. That's why these rays are also called as Rontgen rays. Properties of X-rays: they are electromagnetic waves of very short wavelength. Means X-ray having very short wavelength. As you know, wavelength is nothing but the distance between two successive crust or trough is called as wavelength. And X-ray having very short wavelength means there is inverse relation between wavelength and frequency. X-ray having very short wavelength means they are having very high frequency. X-ray travel with speed of light, that is, they travel with the speed of 3 into 10 raised to 8 meter per second. X-ray affect photographic plates. X-ray are invisible to eyes, but they produce fluorescence in other materials. Means they produce light in other materials, for example zinc sulfide, phosphorus, etc. X-ray having high penetrating power, that's why they kill some form of animal cells also. And X-ray are not deflected by electric or magnetic field, means there is no effect of electric and magnetic field on X-rays because they are electromagnetic waves. And X-ray can be reflected or refracted under certain conditions. Now we will discuss how these X-rays are produced using Coolidge tube method. There are different methods to produce the X-rays, but we are going to discuss how X-rays are produced using Coolidge tube. The principle of this process is when fast moving electrons are suddenly stopped by metal target, then this fast moving electron, that is accelerated electron, loses its kinetic energy into the metal target, and from that X-rays are produced. In this figure, we will see this highly evacuated glass tube which contains cathode at one end and anode at other end. This cathode is maybe the tungsten filament and anode is molybdenum material. This cathode is attached to battery and again it is attached to step up transformer. For anode, above the anode, cooling system is attached to cool the anode, and this anode is used which is having high melting point and high atomic number. When this battery is on, then this cathode get heated, and because of thermionic emission, electrons are emitted from the cathode. These emitted electrons are accelerated by using step of transformer. When these accelerated electron incident on this metal target, they will lose their kinetic energy into the metal target and X-rays are produced. When this accelerated electron interact with metal target, then there are two processes occurs, and because of that there are two types of X-rays are produced. First one is continuous X-ray and second one is characteristic X-ray. Now we will discuss how these continuous X-rays are formed. When this accelerated electron incident on metal target. If it is not having sufficient energy to eject the electron of metal target, then it will just collide with the electrons of metal target, and because of collision it will lose its energy in the form of X-rays. And when it is moving, then it will collide with other atoms in its path, and because of that it will lose its energy continuously, and continuous X-rays are formed. In second process, when this accelerated electron having sufficient energy, then it will penetrate deep into the target atom and it will eject the electrons of target atom. Suppose accelerated electron eject the electrons of K shell, then there is a deficiency of electron in K shell, and this deficiency of electron is filled with higher orbit electron. Suppose K shell electron is ejected and electron from L shell is jumped to K shell. Because of this transition, energy is released in the form of X-rays, and then K alpha line of X-ray is produced. In this way, characteristic X-rays are produced. Now we will discuss about the application of X-rays. These X-rays having very broad application in different field, that is the engineering application. X-ray are used to detect crack in the body of an aeroplane or motor car. X-ray are used to detect manufacturing defect in rubber tires or tennis balls in quality control. X-ray are used to detect flaws or cracks in metal job. X-ray are used to distinguish real diamond from duplicate one. X-ray are used to detect smuggling of gold at airport. Now medical applications. X-ray are used to cure skin diseases and destroy tumors. X-ray are used to cure disease like cancer. X-ray are used to detect bullets position inside the body. X-ray are used in surgery to detect bone fracture. The reason is penetrating power of X-ray through muscle and bone is different. Now X-ray having some scientific applications also. X-ray are used for analysis of structure of organic molecules. X-ray are used for identification of chemicals elements present in the solution. X-ray are used to study structure of substance like cellulose, rubber, plastic, paints,